Hi, this is Dave Dowson coming from Tree Life. Today I've just got a little presentation related to a topic from arboricultural plant health from the Level 6 ABC Awards qualification. We're looking at tree healthcare in relation to the development of new pesticides, biological control and treatments. Over the past 10 years, professionals involved in urban tree management have had to contend with a dramatic increase in pest and disease epidemics, including Pseudomonas bleeding canker, southern oak death, horse chestnut leaf miner, oak processionary moth, Massara canker of London plain, acute oak decline, and Achalara ash dieback, to name but a few. Unmanaged, these pests and diseases will potentially prove devastating to some of our major tree genera. If tree removal and destruction is not considered an option, then managing pest and disease outbreaks relies primarily on treating the tree with either an organic, natural, or synthetic plant protection product, i.e. a fungicide, insecticide, or bacteriocide. Consequently, use of these products has led to a number of concerns, such as the impact on non-targets caused by spray drift, groundwater contamination, accidental contact with the public, and build-up of pesticides resistance by target populations. As a result, there is a general reluctance to use any form of chemical protection. This work particularly comes from Glyn Percival as your reference point. The use of biologicals, an article appeared in the Arb magazine 168 of 2015, page 41. Biologicals, or plant-friendly microorganisms, are living organisms. One of these in particular, and the one that I want to present to you today, is called Trichoderma. Trichoderma to the rescue. As one of the commonest soil fungi on Earth, Trichoderma is robust and interacts with other organisms. Many Trichoderma species act as direct biological controls of several root and foliar diseases. Microorganisms have been waging war against each other more or less since the dawn of life itself. Consequently, we can use these biologicals or plant-friendly microorganisms to fight fire with fire. So what is Trichoderma? Well, Trichoderma species are free-living fungi that are common in soil and root ecosystems. Recent discoveries show Trichoderma species are opportunistic, are virulent plant symbionts, as well as being parasites of other fungi. Are virulent, meaning that they are not virulent to our trees. Trichoderma species grow trophically towards hyphae of other fungi, coil about them in a lectin-medicated reaction, and degrade cell walls of the target fungi. In this way, they're called microparasitisms. And lectin-medicated reaction means that it's the use of proteins that coil around the cell walls in order to degrade them. The trichoderma itself is an antagonistic association between two organisms in which one is adversely affected. In our case, it would be other fungi, and this is called antibiosis. The trichoderma provides competition for nutrients or space. It is tolerant to stress through enhanced root and plant development. It creates tolerance to stress for the tree itself too. They sequester inorganic nutrients, those that might be used by other fungi. One great thing about Trichoderma is that some strains are potent inducers of what's called SAR, systematic acquired resistance, like responses. These responses are actually in the tree themselves. So when inoculated into roots or leaves, Trichoderma can provide control of disease caused by, for example, Botrytis cinerea on leaves spatially separated from the site of application of the biocontrol agent. And they cause inactivation of the pathogen enzymes. Trichoderma harzianum is a fungus that is used as a fungicide. It is used for foliar application, seed treatment and soil treatment for suppression of various diseases causing fungal pathogens. T22 is a particular hybrid strain that has been developed to enhance certain characteristics of its parent strains. These enhancements in disease resistance, environmental tolerance, and crop compatibility make Trichoderma harzianum one of the first biofungicides on the market, sold as HA. So strain T22 utilizes several methods to suppress fungal diseases. First, it forms a physical bond with the root system of the plants, establishing itself in the rhizosphere, and therefore preventing other pathogens from colonizing the soil. This bond and continued growth of the trichoderma throughout the root system forms a physical barrier to plant pathogens. T22 also feeds on excess nutrient content left unused by the root system, which would provide a food source for incoming pathogens. Otherwise, keeping that in mind, Trichoderma does not interfere with mycorrhiza activity or Rhizobium, common nitrogen fixer activity. Secondly, T22 releases chitinases, specific enzymes that denature chitin to break down the cell wall of fungal pathogens in the soil. The holes in the cell wall created by the enzymes turn the pathogenic fungi into prey for other soil microorganisms. The combination of these methods allows Trichoderma to displace other organisms from the soil and the root system to develop additional biomass useful in increasing plant yields. Chitin really is a fibrous substance consisting of polysaccharides. This is a number of sugar molecules that are bonded together. It actually forms the exoskeleton for many insects. A lot of this has been developed at Cornell University. This is where you can find other information related to it. T22 is available either as a powder or granules, and the plant boost that you see on the slide there is only about £6, so not an expensive material. Probably worth giving it a go. Today we have to think of alternative methods in terms of disease resilience for the trees for the future. So this has been just a little introduction into a part of a level 6 teaching and assignment topic. Thank you for listening.